In this lesson, we're going to learn about simple interest. It's our first topic in our investing money unit. So there's a bunch of terminology that you need to go through on these first couple of pages. It's important that you read through and understand what they mean, but also be able to go further than that. For example, understanding what a saving account does and a tax-free saving account is, but also understanding the risk factors. It's really important that we understand what's a higher risk investment and a lower risk investment so that you can actually use this terminology in order to explain situations. If we go on to the next page, we can see that further we go through some more specific terms that are going to help us do some calculations. So again, most of these are working definitions where you need to understand what they mean in order to use them in some sort of context. And we'll see that as we go through some examples. So let's take a look at the first example. Example 1. It says Marty invested in a 2,500 GIC at 2.5% simple interest paid annually with a term of 10 years. So a GIC is a guaranteed investment certificate. Okay, so when we're looking at that, there's different terms for guaranteed investment certificates, so we need to know about those. And for the most part, they aren't that high when we're talking about our risk factors. Okay, so here's our first equation that we're being given. This is our simple interest formula, where I represents the interest, P represents the principal, R is our rate per year. Sometimes we see that as per annum or annually as a decimal. And T is a measurement of time, specifically in years. So that means if we're given any of these values other than rate per year as a decimal, you'd have to change it so that it would be represented as a decimal and per year, and same with time. If it's given in months, you'll have to convert that so that it is given in years. Okay, so that's fine that we know what all of those represent, but what do they mean? Okay, so when we're talking about interest, interest is the money that we've earned on an investment. So if you put a lump sum of money in some sort of investment, so you're giving it to the bank and they're using your money, then you get to collect interest on that. You get to collect a certain percentage of that money, and that becomes yours. The time that you have to keep that money in the investment depends on the terms of the investment. So some are 5 years, some are 10 years, some have no minimum, some have a minimum. Okay, and so the principal, when we're talking about the principal, that's the initial amount of money that you have invested, so your starting value. So if we look at the question here, it says that he invested $2,500. So that would be our principal. Okay, that's the starting value that he's putting in this GIC. How much money he's going to earn is going to earn 2.5%, and that would be our rate. So our rate would be 0.025 because we have to rate that out as a decimal, and that's paid annually. Paid annually means per year. Sometimes it's per annum. And then the term is 10 years, and that is our T value, or time. So what we want to know is, okay, if Marty puts this amount of money in 10 years, how much money has he earned? So he's not allowed to touch that $2,500. It's got to stay there, so he has to be okay to be without that money for 10 years. Okay, so if we use this formula, I is equal to P, 2,500, times R, 0.025, times T, which is 10. And remember, whenever we're given a formula, it's always a good idea to try this out in your calculator. So go ahead and punch those values in, and you should get an I value. Let's go ahead and do that together. 2,500 times 0.25 times 10. We get, I think I lost a 0 there, 0.025. So if I go second enter, I could go and change that. 0.025, there we go. 625. I noticed, and that's a really good thing too, to see $6,250. That's way more than I invested, and I'm only earning 2.5%. There's no way that that value would make any sense. $625, that makes a lot more sense. Okay? So $625 is how much I've earned on this. Make sure you have a $sign at the front. 625, and then you've got 2 decimal places given. All right? Now, the question for A, how much interest will accumulate? That's just how much he's earned. But for B, what is the future value? Future value is referring to the principal plus the interest. Sometimes we see that as FV for future value. That's going to be how much we initially invested plus the amount that we earned. Okay, so our future value in this case was the initial $2,500 plus the extra $625 that we just earned. So our future value, adding those two values together, would be $3,125. So after 10 years, the bank will give you your principal plus your interest back when you're ready to take it all back. All right? Sometimes you can collect your interest along the way. So even though the $2,500 is staying there, each year they can give you a portion of that $625. So if you wanted to know that, right, 625 divided by 10 annually, how much they would give you every year. Okay? All right, let's take a look at C. There's another part to this question. So for C, it says, use Marty's investment to write an algebraic expression that could be used to determine the future value of any investment earning simple interest. So why would we care? Like, why do we want to do that? Well, sometimes we just want to know that future value right away. So instead of doing each piece separately, we're going to put it all together and do it all in one shot. The unfortunate part about using this formula is that you can't just pull out the interest then. So it's a one-shot deal, you just get the final amount. Okay? If you wanted to know just the interest, then you would have to do a second step anyways. But this is making it easier. If we just want the future value, just do a one-step question. So let's start by just letting A be that future value, right? We call that amount or our future value. I'm going to leave P as the principal, R as the interest rate, and T still in our time in years. So because we're using the other formula, then we're not changing any of these variables, right? We said in the previous that our future value is our principal plus our interest. So in terms of what we're doing here, that would be P plus I is equal to A. We also know that our interest formula is equal to PRT. So what we're going to do here is we're going to replace I with PRT and actually just drop that right in its place. So we'll have A is equal to P, and instead of I, we're going to write PRT. So now we've got a formula where we can calculate our future value right away. Another version of this formula, if we factor the P out, that would be P, and then we'd have, if P divided by P is 1, and P divided by PRT would just be RT. Oops. So two versions of this formula, whatever is going to work best for you for whatever situation you're looking at. All right, D says, how would an interest rate of 3.5% change the future value of Marty's investment? And that happens too. Sometimes the interest rate changes, or sometimes you can negotiate different terms and you can get better rates for certain things. So we're going to see if the rate was 3.5% instead of 2.5%, how would that change? So if we're looking at the variables that were given, the only thing that has changed is 3.5. So P stays the same. R is now 0.035, that's our rate, and T has stayed the same. So they want us specifically to see how the future value changed. Now you have two options. You can just calculate the future value with one of our new formulas we figured out in C, or you can go back and figure out I using the I equals PRT formula and then add that on to your principal. So you have a choice here. I'm going to use our new formula just so we can see how it works. So if I use the first version, A is equal to P plus PRT, that would be 2,500 plus 2,500 times 0.035 times 10. Now realize that in this version, you have to be wary of order of operations. So you're going to do the 2,500 times 0.035 times 10 first, and then add that on. So if you do that, you get 2,500 plus 875. So you get a total value, if we add those together, of 3,375. Now, they want to know how would that change? Well, we can see that it's going to be greater, but greater by how much, right? So if we find the difference, we can take this value and subtract it from what we got in B part, where it said how much was our future value, and we got 3,125. So I'm taking that value from right here, where we figured out what our future value was in B, and putting those values in and finding the difference, we get a difference of $250. So $250 more is earned. Now if you wanted to try this question out using the other formula, A equals P times 1 plus RT, you should see that you're getting the same answer. That would be 2,500, 1 plus 0.035 times 10. So you're still going to be aware of our order of operations, and then multiplying that together, you should still get the same A value that we were getting over here. So here this would change to 2,500 times 1.35 if we do that math, and then times that together, you should still get the $3,375. And then the second step would be the same. It's interesting to see that just a 1% change in your interest rate earns you $250 more. However, that is happening over 10 years. But if you can do without 10 years, without that $2,500, then if you can get a better rate, then that earns you more money. Alright, let's take a look at example 2 here. Sunny invested $15,000 in savings account. Sunny earned a simple interest rate of 8%, paid semi-annually on her investment. She intends to hold the investment for 4.5 years, when she'll withdraw all the money to buy a car. Determine the value of the investment at each half year until she withdraws the money. Okay, start by filling out the years for every half year. So we'll start at 0 and we'll go to 4.5, because that's 4.5 years. So every half year, now how do we figure out what her investment's going up by? We know that she invested an initial amount of $15,000. We also know that her interest rate, so we can write this for principal, We also know that our interest rate was 8%, so 0.08. Now for time here, we just want to know how to get from time 0 to time 0.5, not from time 0 to 4.5. So for here, for t, we're going to put 0.5. And if we use our I equals PRT formula, we could figure out what each half year has earned her. Punching all of that into my calculator, I get $600. So to go from year 0 to year 0.5, I add $600. So 600 plus, that would be 15,600. And then the next year and the next year and so on. So go ahead and fill out that whole table for every additional 600 years that she's earned, $600 that she's earned for every half year. All right, so we can see that adding $600 for every half year would get us to a point for Sunny at 4.5 years to have earned has she earned $20,400? Well, no, but her total value, or her future value at the end of 4.5 years, would be $20,400. We haven't seen how much she's earned in terms of her interest. If we want just the interest earned, then we can either subtract out the initial amount, or you can add $600 for every 4.5 years, or times it by however many half years we have there. And then you would actually figure out what the interest is. So be very careful as to how you're recording your numbers or how you're displaying your numbers, because this $20,400 is our future value, not the amount of interest she's earned. All right, let's see this continued on the next page, because they're asking us to do something with these numbers. And that's why we solved this in this way. So maybe every half year, Sunny has arrangements that she gets that $600 mailed to her. So every 6 months, she'll get a check for $600, even though the initial $15,000 has to stay in her investment. Or maybe she has to wait till the term is over. Depends on how the investment is set up. All right, let's take a look at what they want us to do with this continued part. You can see there I have a graph, and we're going to look at that in a moment. So if we use the formula A equals P plus PRT, we should get the same answer that we got in the 4.5 years. So let's see if that's true. So if we do that, our principal was $15,000. And now we're going to use the rate that she had of 0.08, but now instead of a t of 0.5, we're going to use a t value of 4.5. So to see at the end of those 4.5 years, what is her future value? Okay, so if we take that and put that in our calculator, we do in fact get the same value of 20,400. And you can go ahead and check that with your calculators as well to make sure that we're getting the same amount. Now the reason why I have a graph here, what I've done is I've taken all of our data from that table, and you can either do a scatter plot in your calculator, or you can graph it by hand, and I've gone ahead and done that. So I've got the value of our investment over time. So I've got time from 0 years all the way to the 4.5 years, right? And you can see at 4.5 years, we're at that future value of 20,400. So I've taken each of our values and I've plotted them, and you can see this zigzag marks means I didn't start at 0, I started at 1,500, and then I went up by 600 every single time. So you can see, right, where the future value is. I didn't go up by 600 for my scale, but I did for my dots. And what you should be seeing here, what's really important, and the whole point of graphing this, is that this is linear. This graph is a linear graph. We're growing money linearly. So there's a direct relation between your x value and your y value. As time increases by each year, and that's my run, my rise increases by $600. So that's our slope. Okay, so when we talk about slope and we talk about our rise over our run, in this case, my rise is $600 for every 1 year. So the rate, that's not right. It would be $600 for every half year. If we were going to do it per year, it would be $1,200 per 1 year, which is $600 for every half year. And if you wanted to do that using the slope formula that tells us that it's y2 minus y1 over x2 minus x1, you could take any value, any point along your graph, and solve for that, and you would get the 1200 over 1. So let's just write a little statement here. This means that the investment increases at a rate of $1,200 per year, or you can say $600 per half year. So every increase that I've gone with my time, these dots are separated by half years, not full years, right? From 2 to 2.5, from 2.5 to 3, because that's how our table went. And our increase, our up and down increase, is that $600. So horizontal is our 0.5 and vertical is 600. If you want to do 2 points, that's how we got the per year. So that would be 1 year and 1,200. So depending how you're looking at it within your table. And in terms of our equation, we've got A equals P plus PRT. Well, that becomes our y equals mxb formula, because we've got A is equal to 1,500 plus 1,500 times 0.08 times t, if we just leave it as t for any value of time. We've got, this is our b value for equation, and then this is our m value for all of this. So if you rearrange it, 1,500 times 0.08 t plus 1,500, because that's our starting value, right? That would be our y-intercept, and you can see it right here on the graph. Our starting value is 1,500. If I multiply 1,500 times 0.08, we get that 1,200 t plus 1,500. So our equation of our line is exactly that. If you wanted to write it out in terms of y, $1,200 per year times the amount of years, plus our starting value, or our principal, of $1,500. So your y-intercept is 1,500, and your slope is $1,200 per year. Remember, slope is always a rate. So it's always going to be per something. If you wanted to write it $600 per 6 months, you could also write it that way. Alright, the last couple of questions we have here to work through are all examples where we're rearranging our equation to solve for something other than interest. Because we're able to solve for interest, we're able to solve for a future value, but if we're asked to solve for the rate or the time or something, or maybe even the principal, we need to be able to manipulate our equations in order to solve for that. So let's take a look at example 3. Ingrid invested her summer earnings of $5,000 at 8% simple interest paid annually. She intends to use this money in a few years to take a holiday with a friend. A is asking us, how long will it take for the future value of the investment to grow to $8,000? Alright, so let's highlight some key information. We've got our A value, or future value, of $8,000. She's got a principal of $5,000, and she's going to be earning 8% simple interest paid annually. So, writing out all of this in terms of our variables. We've got P is equal to 5,000. R is equal to 0.08. We're trying to solve for time, right? So we don't know what our time is, but we know that our future value is going to be, or we want it to be, 8,000. Okay? So we need to rearrange and solve for t. So if we use our formula, A is equal to P, 1, well, let's use, I was going to use the 1 formula, but we'll use the one with PRT because our t is already out. If I used this one that I was originally going to go with, you're going to be taking extra steps to try to get that t out of the brackets first, whereas in this other formula, t's already by itself. So plugging in what we have, we can start there and then solve for t. So A is 8,000, P is 5,000, R is 0.08, and then t. So let's move everything away from the t and get it by itself. So start by getting the 5,000 away here, create a 0 pair, subtract from both sides. So I've got 3,000 is equal to 5,000 times 0.08 times t. Now you could do this math, but you're going to end up with decimal places. So at this point, what I'd rather do is I just divide both sides by all of that stuff. This cancels everything out here, and now you're left with time is equal to 3,000 divided by 5,000 times 0.08. One word of caution, when you're putting this in your graphing calculator, make sure you put all of that in brackets, otherwise you're going to get an incorrect answer. So go ahead and put that in your calculator and see what you get. I get an answer of 7.5 years. Now, we can't just write that as our answer. Why not? You've done all this math, you've rearranged it, you've got t is equal to 7.5. But I highlighted something up here, paid annually. And when she's paid annually, this means that she can't get that interest except for at the end of each year. So because her interest has been earned at the half year, doesn't mean she gets to collect it at 7.5 years. Ingrid will have to wait till the 8-year mark in order to collect her money. So we'll have to restate our answer and say that it will take 8 years. So don't get confused about rounding. We're not saying that because it's a 5 it would be rounding. This would be the same if we got a t value. Let's say our t value is 7.1. We would still have to say 8 years. If it was 7.3, 8 years, because she has to wait till the end of the term, right? It's an annual term, so she has to wait till the end of that year in order to collect her interest. Now, here's a new formula that we're going to be given. B says, what is Ingrid's rate of return? The rate of return formula says that we have to take the interest divided by the principal and times that by 100%. Okay? So the interest divided by the principal times 100% is our rate of return. At this point, it's really tempting to just go I equals PRT and take that and divide it by the principal. However, if we're going to do that, we need to use the 8 years. Okay, it's really important that we use that 8 years because the time is now 8, not 7.5, which means the initial amount that they're talking about here, this A value, right, of 8,000, we're actually going to, at the end of the 8 years, we're going to have more money than just $8,000. at 7.5 years, we have $8,000. So make sure you make those adjustments per whatever situation you're looking at. So in this case, I is equal to P, which is still 5,000, times R, which is still 0.08, but T, we're going to use 8. So we figure out what that interest is. And if we do that, 5,000 times 0.08 times 8, we get 3,200. So there's actually $200 more there that need to be accounted for our rate of return formula. So rate of return is going to be that 3,200 divided by our principal, which is 5,000, times 100%. And we get a rate of return of 64%. Let's just double check my rounding here. So 3,200 divided by 5,000, 0.64 times 100, 64%. All right. Example 4 is our last question. I think you have what you need in order to solve this one. I'm going to go ahead and do that first. You can hit pause on the videos and try it on your own first, and then come back and check to make sure that you've got the concepts of today's lesson. Alright, so in example 4, Grant invested $25,000 in a simple interest CSB, Canada Savings Bond, that paid interest annually. So if we look here, it says that the future value was $29,375 at the end of 5 years. What interest rate did that produce? So what interest rate produced that future value? So rearranging very similarly to when we were solving for time, now we're solving for rate. And doing this, you would see that 3.5% on a $25,000 CSB would give you a future value of $29,375. Now it says that Grant cashed in the bond after 4.5 years because a house he had been admiring came up for sale and he needed a down payment. How much money did he have for the down payment? So again, remember, depending on how our investments are being paid, the interest is paid annually. He's not going to get the amount of interest that he would have earned if he waited till 5 years. So in this situation for B, our time that we're going to be using is just 4 years. So just making a note for ourselves saying exactly that. Use T as 4, not 4.5. Once you do that, then you can go ahead and use your A value, or your A formula again. We want to use this one this time, P1 plus RT. So our future value would be our 25,000, 1 plus 0.035 times 4. Punching all of that into our calculator, we get a value of $28,500. So that's the amount that would be available to him, his principal plus the interest for 4 years, to be able to cash that out and use for a down payment. That's it for today's lesson. Just to go back and have a look, don't forget to go over all of those terms. We learned a new formula, I equals PRT, which is called simple interest. Important to identify simple interest because we're going to learn about compound interest in another lesson. You need to be able to differentiate between the two. Also seeing that when we do this as a table, right, we have the same amount being earned every half year, or if we're going to count up every year. And when we graph that, that gives us a nice straight line graph, which means that simple interest is a linear function. Also, if we go back a step, we learned about our future value formulas. We came up with this using our interest formula and our principal, putting those together to get our future value, and we can use different forms of that equation depending on what we need to solve for, and that we're not always solving for interest and our future value, but sometimes we're going to solve for our time or our rate or even our principal, depending on the situation. Thanks for joining me today.